All right, so here we're supposed to solve the system, and now they say if possible. All right, so that's always the case, if possible. Sometimes you're going to get no solution, sometimes you'll get infinitely many solutions, and so you always have to test it. So first things first, let's eliminate this x, because guess what? We can easily do that by just adding the two equations together, and so we get 2y plus 2z is equal to 15. And then we have this equation, y plus z is 4. And so if we take it times a negative 2, we can eliminate that y or the z. It doesn't matter which, because guess what? They both get eliminated. And so we get 0 is equal to 7. That doesn't make sense. 0 does not equal 7. And so that's a contradiction. So that means there's no solution to this system of equations. And so when we get to this, something like this, that's always nice because we know then we're done. There's nothing we can do here. And so we just say no solution. What about this one? Here we're going to add these together. Let's add the y's together, or add these just together to get rid of the y's. And so when we do that, we get 2x plus 2z is equal to 8. Now, if we take the first and the third, then we can say, okay, well, then we get what? 4x plus 4z is equal to 16. And so now if we take a negative 2 times this equation and add it to this equation, we're going to get this. And guess what? Here we get 0 equals 0. Well, that's true. And so what that means is we have an identity here. And so that means it's going to be an infinitely number of solutions that can work here. So that's going to be kind of the nice thing. No matter what solution we plug in, it's going to work for all of them. So that's going to be a key case. And so what we can say is the variables can be written in terms of z by solving here. So 2x plus 2z equals 8. Solve for x is 4 minus z. All right, so to find y in terms of z, what we're going to do is we're going to substitute that in for x in the first equation. And so if we do that, then we get y equals 2. And so the solution set is 4 minus z, comma 2, comma z. And that's going to be whatever z we plug in, that's going to be the solution to our equations. And so this gives us the specific. So if we plug in z as 1, we get 3, comma 2, comma 1. If we plug in 4, we get 4 minus 4 is 0, comma 2, comma 4. So infinitely many solutions to this equation, and there's multiple ways to write it. Sometimes this is the way to write it. Sometimes you just write infinitely many solutions, and so it kind of depends on what they're going to ask you to write as far as your solution goes. Do they just want infinitely many solutions? Do they want it in terms of z, or how they want it? You have to follow what they ask for. All right, so that's all I have for this section. Hopefully that will help.